Hello dear students, welcome to my channel. Today we have a very interesting topic, that is counting techniques, which is a very important part of discrete mathematics. Now you see, counting is the process of determining the number of elements of a finite set of objects. So this is actually the counting. Now mathematics began with counting and numbering. To understand the roots of mathematics, we must go back to the time when numbers were first used, which is a most difficult task. Now if you see the history, there is archaeological evidence suggesting that humans have been counting for at least 50,000 years. Counting was primarily used by ancient cultures to keep track of social and economic data, such as the number of group of members, prey animals, property and debts. So you see, the counting has a great importance from past. So today we'll see in our lecture video about counting techniques, rules and the permutation combinations. So there are two basic counting principles throughout. One is a multiplication rule, another is a sum rule. So what is a multiplication rule? If a work or experiment A can be done in M ways and another work or experiment B can be done in N ways, then there are M cross N possible ways when both of these experiments are performed. So you see, an experiment or work has to be done in M ways. So there are M ways, this is M ways, suppose, and then work B or job has to be done in B ways, N ways, this is N ways. So if both of them are performed, if both of these experiments are simultaneously happening, then there are M cross N ways. Total number of ways is M cross N. This is your multiplication rule. M cross N possible ways when both of these experiments are performed. So in general, if there are A1, A2, A3, AN, etc. ways, they are occurring in N1, N2, N number of, and N3, N4 ways, then the event can occur simultaneously in N1, in general, this is in general, N1 into N2 into N3 ways. So this is the multiplication rule, etc. Let's go ahead. So this is the most fundamental rule of counting, one of the most fundamental rule, multiplication rule. Suppose for example, St. Xavier's College offers, so this is your St. Xavier's College, it's offering three courses in the morning. Morning has three courses. Suppose in the colleges you have courses commerce, arts, science. So 3 courses in the morning and 7 courses in the day. Seven courses in the day and 5 courses in the evening. So this is the college offering courses. So 5 courses in the evening. So this is 7, this is 3, this is 5. Now find the possible number of choices when the student who wants to study one course in the morning, one in the day. Look at that, the question, one in the day and one in the evening. That is not physically possible. But in case of this problem, I want to discuss the problem or the concept of the problem. So in that case, if we want to choose a course in the morning, in the day, in the evening, then how many ways he can choose? Or now what is the number of possible choices? The number of possible choices is 3 into 7 into 5, because you have to apply multiplication rule. Why? Because he wants to choose a course in the morning and a course in the day and a course in the evening. So all the things are happening simultaneously. So all the experiments are going on simultaneously. So in this case you have 3 choices, in the day you have 7 choices, in the evening you have 5 choices. So total number of ways is 3 into 7 into 5, and that is equal to 105. Okay, so this is the number of ways. Clear? Now look at that another experiment. A man wants to travel from Howrah station to New Delhi via Kanpur. There are 6 routes from Howrah to Kanpur. So let us just draw a sketch. Sketch will be help you to make understand. This is Kanpur and this is Delhi, New Delhi. So this is Kanpur and this is Delhi, New Delhi station. So there are 6 routes from Howrah to Kanpur. You see there are 6 routes available and different trains, you know that. So I am talking about that route 5 and another one is 6. So there are 6 routes from Howrah to Kanpur, and from Kanpur to Delhi there are 5 routes. So look at that, there are 5 routes. And there are 5 routes. Okay, so there are 6 routes available from Howrah to Kanpur, and from Kanpur to Delhi there are 5 routes. So in how many ways he can travel from Howrah to Delhi? So a person wants to go to from Howrah to Delhi, in how many ways he can go? So look at that. Here for Howrah to Kanpur he have 6 choices. So for each route from Howrah to Kanpur there are 5 choices. Kanpur to Delhi there are 5 choices. There are 5. So for each there are 5. So in this way you can apply the multiplication rule. So in this case the multiplication rule, if you apply, the answer will be 30 ways, because for each route from Howrah to Kanpur there are 5 routes from Kanpur to Delhi. So for suppose choosing you are the first route, for this first route there are 5 choices, for the second route there are 5 choices, for the third route there are 5 choices, and so there are for 6 routes 5 choices. So 6 into 5, 30 ways. So this is how you will apply, because both the routes he has to select, because we have to select both the routes, Howrah to Kanpur, Kanpur to Delhi. That is the both the work is happening simultaneously. Okay, so these experiments are performed simultaneously. So that is why the multiplication rule you have applied. So clear? How will you apply the multiplication rule? Now let us go to the sum rule. If similarly, if A has m ways, B has n ways, then there are m plus n possible ways when exactly one of these experiments are performed, either A or B, but not both. So if one of these experiments are performed, your possible number of ways will be m plus n. You look at that, your possible number of ways will be m plus n if one of these experiments A and B are performed, not both. So in general we can say A1, A2, A3, etc. One of them, all are independent, all are independently occurring. So all of them are independent at the same time. So what is the general? General one is n1 plus n2 plus n3 if one of the events A1, A2, A3 are happening. So this is the general case. Okay, clear? So this is the sum rule. Let us have to the same question. St. Xavier's College offering 3 courses in the morning, 7 in the day and 5 in the evening. Then in this case, what is the number of ways? Number of ways a student can select exactly one course. Look at that, the question is a different way. One course either in the morning or in the day or in the evening. So he or she wants to choose a course in the morning or in the day or in the evening. So not all the courses in morning, day and evening. So in this case you have, look at that, you have 3 courses in the morning, 3 or 7 or 5. So 15 ways, because you are choosing one of the courses, not all simultaneously. So that is why you are applying here sum rule. In that case, you are, in the previous case multiplication rule, you are choosing all the courses in the morning, in the day and the evening. One course in the morning, one course in the day and one course in the evening. That is why there is a multiplication. But here you are choosing either a course in the morning or in the day or in the evening. That is why you have the addition, that is 3 plus 7 plus 5 equal to 15 ways. Now look at the next question in a different way. Suppose you are at Howrah station. This is the Kanpur and this is the Delhi, New Delhi. So you are, now the question is, the thing is that 6 routes, you have the routes are 6. That is the same. And here you have 5 routes. So you have the 5 routes. from Kanpur to Delhi. Now the look at the question. So you are in, okay, now the question is, in how many ways you can leave the station Kanpur? Suppose you are in Kanpur, in how many ways you can leave the station Kanpur? So you have two choices, either you can go from the Howrah side or you can leave from the Delhi side. So you can leave towards Delhi or you can leave towards Howrah. So you have either Howrah or Delhi. So you have 6 plus 5 choices. So 11 ways you can leave the station Kanpur. So this is how your addition rule and multiplication rule. In that case you have multiplication because you have to choose both the routes from Howrah to Kanpur, Kanpur to Delhi. But in this case you have to leave the station Kanpur. Either you can go towards Howrah or towards Delhi. So you are applying some rule. Okay, clear? So these are the two basic rules of counting techniques, multiplication rule and sum rule. Let us now proceed. Let us now move to the another problem. In how many, look at that the question, how many 5-digit or 3-digit numbers can be formed by using 1, 2, 3, 4, 5 without repetition? So let us have a box. Suppose you are filling the box 1, 2, 3, 4, 5 because you are asking 5-digit number. So it's just like you are filling the boxes with the digits 1, 2, 3, 4, 5. So you have numbers 1, 2, 3, 4 and 5 and you are filling the boxes 5 places. So for the first place you have 5 choices and look at that, without repetition. First you are doing without repetition. So I am writing WOR without repetition and WR with repetition. So in the first case you have without repetition. So you are filling the first position with 5. You have 5 choices for the first position, 5 ways. Next, already you have taken 1, so you have 4 choices. So second place can be filled up by 4 ways, third place can be filled up by 3 ways, and fourth place can be filled up by 2 ways, and the last place can be filled up by 1 ways. So you have 5 into 4 into multiplication because you are filling up the position simultaneously. So you will apply here multiplication rule. So your multiplication rule will be 5 into 4 into 3 into 2 into 1, and that is equal to factorial 5. So factorial 5, that is equal to 120. That is called the factorial notation, is factorial 5. What is factorial? Factorial n is the product of first n natural number. Factorial n is the product of first n natural number in the decreasing order. If you say n into n minus 1 into n minus 2 etc. and so on, 3, 2, 1. So this is called the factorial notation. Okay, either this notation or somewhere you can see this is the notation of factorial. So in this case without replacement the answer is 120. So there are 120 ways to filling up the 5-digit place with the 5 numbers without repetition. Now with repetition for the first place you have 5 ways, and for the second place you have again 5 ways, because with repetition you can repeat the digit already used in the first place. Again in the third position you are using 5 ways because you can use the digit because you are using with repetition. So in this way 5 into 5 into 5 into 5. So you have 5 to the power 5 ways for with repetition case. Clear? So without repetition there are 5 into 4 into 3 into 1. Multiplication, in this case also you are applying multiplication rule, but you have 5 choices for the first position, 5 choices for the second position, 5 choices for the third position, 5 choices for the fourth position, and 5 choices for the fifth position. So you have 5 into 5 into 5 to the power 5 ways for with repetition, and in the previous case you have without repetition. Clear? So this is very carefully you have to make it clear that without repetition and with repetition, these two cases are very important. Now go to the 3-digit number, second case. So second case you have 3-digit number. So for 3-digit number you draw 3 boxes or 3 places. You are assuming 3 boxes and you have 5 numbers 1, 2, 3, 4 and 5. Okay, so you have 5 numbers. Now 1, 2, 3, 4, 5 you can fill up the first position in first case is a without repetition. So I am writing WOR, without repetition. So for the first position you have 5 choices. For the second position you have 4 choices because you are without repeating the digits. And for the third position you have 3 choices. So you have 5 into 4 into 3. Total number of ways without repetition case. So it's a 60 ways. So you have 60 ways for the first case, that is without repetition. So with repetition, what are the number of cases? For with repetition, for first place you have 5 choices. For the second place you have 5 choices. And for the third place you have 5 choices. Because you can use the digit already used in the first place. So you have 5 cube ways. Number of ways is 5 cube. That is 125 for with repetition, if you repeat the digits. So this is how you are applying the multiplication rule and addition rule wherever required. So you go to the concept and understand the concept. After that you apply that rule. Clear? Next we'll move to the permutation combination now. So before that I will give you an example, very interesting example. Suppose A, B, C, D are 4 friends. A, B, C and D are 4 friends, want to see the IPL match in Eden Garden, suppose. So they want to see the match. So but after they arrived at the field, they found that there are only 3 tickets available. 3 tickets. But there are 4 friends. So one friend has to sacrifice. So suppose in how many ways? So in that case you have to sacrifice one friend. So in how many ways you can select or group the friends? So in this case, suppose ABC will go to the match or want to see the match, or ABD. In that case C has to sacrifice. In this case D has to sacrifice, or ACD or BCD. So this is the grouping or selection. So this is, suppose ABC now entered the, ABC bought the tickets and ABC want to see the match. Now they have entered the field ABC. So D has to sacrifice in the case. So ABC entered the field and they found that there is a seat number S1, S2, S3. Now the question is in how many ways they can take their positions or take their seats. In how many ways, or in how many different ways. So in that case you can see they can take their positions in like ABC or ACB or BCA or BAC or CAB or CBA. So this is the number of ways. So I have a problem, very practical problem. So in the first case where you are selecting the or friends, this is actually selection or combination. This is actually combination. There is no arrangement. This is actually combination or selection or grouping. And in the second problem, in the second case, that is when you are arranging or you are taking the positions, this is called permutations. Permutation or arrangements. Permutation or arrangement, in the first case we have combination. This is combination and this is your permutation or arrangements. So what is the main concept? The concept is order of appearance of things is taken into account in permutation. In permutation, very careful, in permutation, in this case, the order of appearance of things is taken into account. But in combination, order of appearance is not taken into account. Here the order is not important, but in this case order of arrangement is important. In this case only the things selection or grouping is important, but here order is important. So whenever there is a order or arrangement of things or order of appearance is important, that is called a permutation. Okay, so this is your concept of combination on permutation. So now let's move forward. There are number of permutations. Suppose first one, I want to discuss the first formula for permutation and some notations. So first one is number of permutations of n different things taken r at a time. So that is NPR, that is written as NPR. The notation is NPR, number of permutations of n different things taken r at a time, n greater equal to r, all are different things. So how you will explain this, and that result equal to this result equal to factorial n. Already I have discussed about factorial, that is product of n natural numbers, factorial n by factorial n minus r. So this is your factorial notation, factorial n by factorial n minus r. So how will you work this? I will explain this very shortly. Suppose there are n boxes, 1, 2, etc. r. Suppose there are r boxes, 1, 2, 3, 4, 5, etc. r. So first, and there are n different objects. N different objects are, suppose a1, a2, etc. an. These are the n different objects. These are n different objects. So for the first place, you have first place can be filled up by n ways. Already we discussed about this in the previous problem. Second place can be filled up by, now there are n minus 1 things left, remaining places can be filled up by n minus 1 ways, and third place can be filled up by n minus 2 ways, and lastly the last place, that is the rth place, is filled up by n minus of r minus 1, that is n minus r plus 1 ways. So what is the total number of ways? You are filling all the places simultaneously. So n into n minus 1 into n minus 2, etc. into n minus r plus 1 ways. This is the total number of ways of filling the r different places. Okay, by multiplication rule. This is by multiplication rule, because all the places are simultaneously you are filling up. So this is equal to NPR. This is equal to NPR. So this is the result actually, NPR. You are filling up n places, first place by n ways, second place by n minus 1 ways, and the rth place by n minus r plus 1 ways. So this is the product NPR, and this is equal to nothing but you want this expression. So it's very simple, n into n minus 1, and last one is n minus r plus 1. Second bracket, I am multiplying the numerator and denominator by r into 3 into 2 into 1. The next step, that is n minus r. So I am multiplying the denominator and the numerator by n minus r into n minus r minus 1 into etc. 3, 2, 1. Look at that, I am multiplying the numerator and denominator by n minus r minus 1 into 3 into 2 into 1. So that is nothing but this is your factorial n in the numerator, and in the denominator you have factorial n minus r. So this is the result of NPR. Okay, clear? So this is the result when n different things taken r at a time, number of permutations of n different things taken r at a time. The result is NPR equal to factorial n into factorial by factorial n minus r. Let's move to the next formula, that is number of permutations of n different things taken n at a time, taken all at a time, that is you are taking n at a time. So in this case the result is nothing but your factorial n, because the result is NPN, that is equal to factorial n, that is in factorial n ways. Okay, so this is because you are taking all at a time, all the different numbers or different objects at a time. So this is NPN, that is equal to factorial n. Find the number of ways. Next question, I want to solve one question on permutation so that you have a clear idea about this. Find the number of ways in which the letters of the word history can be arranged. So history, how many words in history? Letters 1, 2, 3, 4, 5, 6, 7. So there are 7 letters. So you are taking all. So your answer in the first case is 7p7. That is factorial 7 by 7 minus 7, that is factorial 0. And your factorial 0 is 1. That is, you try this. Very interesting result. Factorial 0 is 1. This is as an assignment. Students should try that. How the factorial 0 is 1. Here also we are having in the denominator factorial 0 because n minus r, because the result is factorial n by factorial n minus r. So you have factorial 0 and that is equal to 1. So that is why it is factorial n, and 7p7 is factorial 7. That is, all are different. You look at history, all the letters are different. Now the second question is, in how many ways, how many of them begin with H and end with Y? So your all the letters are begin with H and end with Y. So you are fixing the first place and the last place. In between you have 5 places. So there is no arrangement in the first and the last position, but you have an arrangement in the in between 5 places. So you have 5 letters because H and Y gone. So you have ISTOR. So 5 letters and 5 places. In how many ways you can arrange? 5p5. So you have, your answer is factorial 5. This is how your arrangement is when all the letters are, or all the objects are taken together. All the objects are taken together, or some letters are taken together. So factorial 5 is the answer. Okay. Now another formula: number of permutations of n different things taken all together when the things are not all different. N things taken together not when the things are not all different. This is a very important one. When the things are not all different. So suppose there are n things, out of these n things, p things are alike of one kind. Suppose p things are identical, q things are identical, out of them identical of the second kind. This is the first kind. Also r things are identical of the third kind. So this is how out of n things, and others are different. Others are different. Out of n different things, out of n things, there are p things identical of first kind, q things identical of the second kind, r things are identical of the third kind. And suppose let the required number of permutation be x. Let x be the required number of permutation. Required permutation. Number of permutation. Required number of permutation. So, and suppose p things can be arranged among themselves in factorial p ways. P things can be arranged among themselves in factorial p ways. Q things can be arranged among themselves in factorial q ways. And r things can be arranged among factorial r ways among themselves. So this, suppose this is the okay. This is okay. Now, if we replace p identical things by p different things, suppose if we replace p identical things by p different things, very carefully please note that if we replace p identical things by p different things, then which are also different from the rest of the things, then the number of permutations will be x into factorial p. Clear? If we replace p identical things by p different things which are also different from the rest of things, the number of permutations will become x into factorial p. Similarly, if we replace q identical things by q different things, then the permutations will be x into factorial p into factorial q. And also lastly, r identical things by r different things, then the number of permutations will be x into factorial p into factorial q into factorial r, applying the multiplication rule. and that is equal to factorial n, because total number of things is n, total number of things is n. Out of these, m things are identical, q things are identical, r things are identical. So this result equal to factorial n. So that implies x is equal to, very important result, x is equal to factorial n by factorial p into factorial q into factorial r. So this is how you will apply the formula when all the things are not all different. All the things are not different. So let us have some problem. How many words can be formed with the letters of the word statistics? So by rearranging, look at that, the letters are not all different. You have 3 S's. Look at that, you have 3 S's, 3 I's or 3 T's, sorry, and 2 I's. You have I letter twice, 3 letter, T letter thrice, S letter thrice. So what is the total number of letters? And total number of letter you see 10. So your answer will be factorial 10 by factorial 3 into factorial 2. Clear? Because and all other are different. There is no repetition in all other. So like you are applying factorial n by factorial p, factorial q, factorial r. P things are identical of one kind. So S, this is identical of first kind. This is identical of the second kind. And this is identical of the third kind. So you are applying that rule, previous rule, factorial 10, total number of letter is 10. So factorial 10 by factorial 3 into factorial 3 by into factorial 2. This is the required answer. So in this way you can apply this formula to the problems where all the things are not different. Okay. Now we have a next problem. The next formula, we must say this is a formula. Number of permutations of n different things taken are at a time when each thing can be repeated any number of times. Already we have discussed about this. So suppose there are n r boxes. Again we will say there are r boxes 1, 2 and etc. r. So there are r number of boxes and you have n different things. For the first place you have n choices, any number of boxes you can, there is repeated any number of times. So there is no restrictions or repetition. There is no restriction on repetition. You can repeat the digit. So for the first place you have n choices, for the second place you have n choices, and so on. For the rth place you have n choices. So your total, you will apply multiplication rule because all the boxes are simultaneously filling up. So you have n to the power r choices. This is your answer. So this is the formula. So let us apply now. So we have a problem. How many 4-digit numbers can be formed by using the digits 1, 2, 3, 4, 5, 6, 7 if at least one digit is repeated? So at least one digit is repeated. So let us have the problem. So you have 4 digit. So you have 4 boxes, 4 places, and suppose if digits are repeated, sorry, suppose digits are repeated. So if digits are repeated, your number of ways is, for the first place you have 7, second place you have 7 choices, for the third place you have 7 choices, so on. So the number of cases will be 7 to the power 4 ways, multiplication rule. Clear? If repetitions are not allowed, without repetition, so without repetition you have 7p4 ways, because for the first place you have 7 choices, for the second place you have 6 choices, for the third place you have 5 choices, and for the last place you have 4 choices. So 7p4 ways. So what is the total number of ways now? What is the answer? Answer is simply 7 to the power 4 minus 7p4, because your at least one digit is repeated. 7 to the power 4 minus 7p4. This is the answer. Okay, this is the required number of ways. Clear? So this is very important. You look at the problem and carefully do the problem, because at least one digit is repeated. Next, go to the permutation under restriction. There are some restrictions on, so I will discuss those problems also. There is restrictions on permutation when particular objects are never together. So suppose look at the problem. Find the number of ways in which 5 girls and 5 boys can be arranged in a row if no 2 boys are together. So you have 5 girls and 5 boys. So you have to arrange in such a way that no 2 boys are together. So first you place the girls in 5 places. So G, 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 G and G. Girls, you have placed the girls in 5 places. So you can place the girls in factorial 5 ways or 5p ways, 5p 5 ways. So girls can be arranged among themselves with factorial 5 ways. And look at the places in between them. If you put the boys, they will be separated. 1, 2, 3, 4, 5, 6. There are 6 places in between the girls and before the girls and after the girls. So there are 6 places. If you put the boys in these places, boys, 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 so boys will be separated. Like for example this. Or you can put here. So there are 6 places for 5 boys. So what is the number of ways of boys? So boys can be arranged in 6 places. 5 boys is 6p 5 ways. So total number of ways is a multiplication. Why? Because you are doing the jobs, that is arranging the girls and the boys simultaneously. So there is a multiplication. So this is the required number of ways. Clear? So this is the answer. So there is a restriction that boys should not be together. Clear? So this is the required number of ways. And why multiplication? Because boys and girls are arranged simultaneously. Now when particular objects are placed always together, there are some cases when particular objects are always together. So I am talking about some examples. Suppose in the best and waste, if the best and the worst papers never appear together, find in how many ways 6 examination papers can be arranged. So if you take the best and worst paper together, that is best and worst, so it will be together, then it will be taken as a 1. Then number of papers will be 5. 6 examination paper total, and you are taking best and worst paper 1. So your total number of paper will be 5. So 5 papers can be arranged among themselves in factorial 5 ways. Okay, but 2 papers can be arranged among 2 ways. Best and worst paper can be arranged among themselves in 2 ways. So factorial 5 into 2 when the best and worst papers are together. When the best and worst paper are together. Okay, but we want never together. So what is the total number of arrangement if there is no restriction? Factorial 6. If there is no restriction, then what is the total number of ways of arrangement? Factorial 6 or 6p6. So factorial 6 minus best and worst paper together. So this is the required permutation. This is the required answer. Okay, so what I am doing? I am doing factorial 6. Why? Because 6 papers are arranged without any restrictions. And why this one? Because I am taking best and worst paper together. So if you take best and worst paper together, it will be 1. So total number of papers will be 5. So factorial 5 ways, and best and worst paper can be arranged among themselves in 2 ways. So factorial 5 into 2. So factorial 6 minus factorial 5 into 2 is the number of ways. So this is your answer. Let's come to the last problem of our discussion today, of our lecture today. In how many ways can the letters of the word business be arranged so that vowels will occupy the odd places? So business, how many vowels you have? So you have a 8 letter, right? Business, you look at that, there are 8 letters. So out of 8 letters, your vowels are U, I, E. 3. So you have 3 vowels. You have 3 vowels and 5 consonants. So how many places you have? You look at that, there are 1, 2, 3, 4, 8 letters. 5, 6, 7, 8. So there are 8 places. Now there are how many odd places? Odd places are 4. 1, 3, 5 and 7 odd places. So 3 vowels, you look at the restrictions, vowels always occupy the odd places. For 3 vowels you have 4 odd places. So how many ways you can fill up the positions? 4p3. 4p3 is the places. 4p3 is the number of ways of vowels, for 4 odd places. So you can arrange the vowels in 4 odd places in 4p3 ways. Now for the consonants you have 5 places, and out of these 5 consonants there are repetition of 3 s's. So how many ways you can arrange the consonants? factorial 5 by factorial 3, because there are three identical things applying that formula. So this is the required number of ways of vowels occupy the odd places. So factorial 5 by factorial 3 is the number of arrangement of consonants. This is the consonants, and there are 3 repetitions of s's, and this is the number of arrangement of vowels. So this is how you will apply the permutation, restricted permutations, that is things are together, things are not together. This is how. So I hope today's video will be helpful to you. This is a very important video because it will give you the idea of multiplication rule, sum rule, permutation combination, the basic concept of permutation combination, how to deal with the problems of permutation. So subscribe my channel and just follow my videos. I will put the next video on combination. Thank you.